Okay, so for the last 2 weeks of our school year, we're going to talk about rational exponents. Now, first of all, when I say the word rational, what I mean is a fraction. So really what we're going to talk about is what happens when the exponent is a fraction. So I'm splitting this up into two parts. For part one, we're going to kind of make it easy, ease in, and we're going to say the numerator, the number on top, is always going to be a 1. So we're going to be looking at something with an exponent like 1/2 or 1/5 or 1/20th or 1 over 100, but the idea is that top part will always be a 1, and then for part 2 next week we'll take a look at what happens when you get a different number up there. So if you have an exponent that's a fraction and the numerator is a 1, what it actually is a radical. So that's good. That means what we're doing is we're tying together the last two things we've done. 2 weeks ago we reviewed exponents. Last week we learned about radicals. So basically if I have x to the 1 over b power, and I'm just using b to stand for any number, what it actually ends up being, you take that x, that number that was being raised to the 1 over b power, it turns into a radical where the index of the radical is b. Now sometimes things are a little confusing in the notes when I talk about b or c for a constant, so let's throw a couple numbers in there and see what it looks like. If we were talking about x to the 1/3 power, that's the same as cube root of x, or the third root of x. And if we were talking about 5 to the 1/10 power, that's a radical too. That's the same as the 10th root of 5. So basically, when you're looking at these things, whatever number you see here turns into the index of the radical here. A 1/3 power is a third root, or a cube root. A 1/10 power is a 10th root. So what's good, and I mentioned this earlier, we just learned radicals. That was the thing we did just last week. So basically, these are going to be the same questions we did last week. They're just written a different way. Instead of seeing a radical, you're going to see a fraction exponent, but it means the exact same thing. So here's our first example. Let's say I ask you to evaluate 49 to the 1/2 power. Well, to evaluate it, the first thing you want to do is rewrite it as a radical. So I'm going to take that number, that 49, and instead of writing it using a rational exponent, I'm going to write it as a radical. Now remember, this number here is the index, the one that goes here. So what we really have is the second root, or the square root of 49. Now remember, when it's a 2, you don't even really need the 2 there. The second root of 49, we usually just write like this. But either way, the answer to the question is actually just 7. Because remember, a square root, or a second root, is asking you what number times itself equals 49. And the answer to that question is 7. All right, let's do another example. Now instead of evaluate, we're going to simplify. And we have x to the 7th power, and we're raising it to the 1/3 power. So let's start the question the same way we did the last one. Let's take that x to the 7th, and instead of writing it as a fraction exponent, let's write it as a radical. Now again, because I had a 3 here in the denominator, that's the index of my radical. So by understanding rational exponents and rewriting as a radical, we've turned it into a question exactly like the ones you did last week. I'm just asking you, what is the cube root, or the third root of x to the 7th? Now as a quick reminder of how we did that from last week, remember what you're doing is you're basically factoring out groups of 3. You're saying x to the 7th is 1, 2, 3, 4, 5, 6, 7. It's x times itself 7 times. Now if I'm doing a cube root, then every 3 x's can be brought out to turn into 1, because the cube root of x cubed is just x. And here's 3 more. Now I have 1 left over, so I'm going to leave that one. Whatever's left over stays in the radical, and what I brought out front, x times x, is x squared. So there's your final answer. That was a review of how to simplify using variables. So my final answer to that question is x squared times the cube root of x, or, and I'll just show you a second way to write this answer. If you wanted to, you could write it as x squared times x to the 1/3 power, because remember, that's the same. This cube root of x can be written as a 1/3 power. So either of those, I'll box them both up. Either of those answers are fine. We now know 2 ways to write the same thing. Let's do one more example, and then we'll call it a day. So we're going to do a simplify again, and we're going to take a look at the ones like last week where we kind of worked up to this, where all of a sudden it's everything mixed together. We have numbers, we have variables, we have a whole bunch of stuff. But the first step is to rewrite it as a radical. So take everything inside the parentheses. That's 250 a to the 5th b cubed. And let's turn that into a radical. This is going to be a cube root again, because I did a 1/3 power again. So if I rewrite this question, it's the cube root of 250 a to the 5th times b cubed. So if you remember from last week, the number part is actually the hardest part. So let me go off to the side here. I'm going to do a factor tree. I'm going to take that 250 and I'm going to start breaking it up. And let's say the first thing I notice is 250 is 25 times 10. Whenever a number ends in 0, it's good to factor out that 10. And then 25 is 5 times 5, and 10 is 5 times 2, and none of those numbers can be divided out anymore. So if I factor 250, what I get is 3 5s and 1 2. So let's go back to our question here, our cube root question. I'm going to leave myself some space here to write it all out. The 250 ends up being 5 times 5 times 5 times 2. And then we have 5 a's, 1, 2, 3, 4, 5. And then we have 3 b's, 1, 2, 3. Now because it's a cube root, I'm looking for groups of 3. I have 3 5s, so let me set up for my answer here. I'm going to draw my blank cube root in here. I have 3 5s, that'll give me 1 5 out front. I have 3 a's, that'll leave me, or that'll bring 1 a out front. And I have 3 b's, that'll bring 1 b out front. So I have 5 ab out front. Now what's left over is a 2. And an a times a, which is a squared. So inside the radical would be 2a squared. And that right there is our final simplified answer. So just remember, you guys, we are repeating questions from last week. You already know how to do this. We're doing our radical work. We've just learned a new notation for it using fraction exponents, or what we call rational exponents.